In this video, let's solve source transformation, one more problem. Using source transformation, find current I. You can see the circuit. So here you have dependent current source, that is voltage dependent current source. This current source is depending on Vx, current flows to that is I, so that Vx equals to 2 into I. Voltage dependent current source, and it is having secant. Find the current that flowing through the 2 ohm, so that you need to convert this 5 ampere 3 ohm current source and 1 ampere 9 ohm current source into voltage source. Okay, so by converting that, you can get the voltage source V equals to I into R, whereas I is 5 ampere and R is 3 ohm. So you can get 15 volts and 3 ohm, that is in series with 4 ohm. Again here, by converting that 9 ohm 1 ampere, you can get V equals to I into R. 1 into 9, you can get 9 volts, that is in series with 9 ohm. And the polarity, see the direction of current upward, tail end indicates minus, arrow end indicates plus, so that you can get plus minus and plus minus for the both voltage sources. Now you need to convert this current source into voltage source. Okay, so by converting that, you know that V equals to I into R, whereas I is nothing but 3 into Vx, R is nothing but 17, so that you can get 51 V into X, whereas Vx equals to 2 into I, as they mentioned in a circuit diagram. So now you convert this voltage source into current source, so that you can get I equals to V by R, 15 by 7 amperes, then 7 ohm and 7 ohm are in parallel. By reducing this equivalent circuit, you can get 3.5 ohm. Similarly, 17, 2 and 9 are in series, so that you can get one more equivalent resistor, that is 28 ohm. Okay, so now once after reducing this 7 ohm resistor, now we'll get, after that you convert that current source into voltage source, you can get V equals to I into R, whereas V is given by I into R. I is 15 by 7 and R is 3.5 ohm. You can get 7.5 volts is in series with 3.5 ohm resistor. So now we can see 3.5 ohm and 28 ohm are in series, and it is closed loop. Now it becomes, you need to find the value of current I that flows by applying KVL. Before that, I'll reduce the network. 3.5 and 28 are in series, you can get 31.5 ohm. So now we'll be having one closed loop circuit. Apply KVL. Okay, by applying KVL, you'll get the value of current I. So first I'm giving the loop direction along with the current I, then I'm marking the polarities based on the direction of current, voltage sources as it is, but for the resistor current is flowing from higher potential to lower, so that plus minus. Then by applying KVL based on the loop direction, I'm marking the second polarity. Then I will write the equation, plus 7.5 by marking the polarity, plus 51 into Vx as it is a voltage source, minus 31.5 and current flows to that is I, so that minus 31.5 into I minus 9 equals to 0. But Vx, you know that is 2 into I. So this is a KVL, a summation of EMF and resistive drop equals to 0. But Vx equals to 2 into I. By substituting that value, you can get 7.5 plus 51 into 2I minus 31.5 minus 9 equals to 0. This solve with the help of calculator. For the calculator, you need to solve one unknown equation just by writing, instead of I will consider alphanumerical A. So now I'll substitute the values. 7.5, okay, the numerical values, 7.5 plus 51 into 2 into 2, instead of I I will write alpha numerical A, alpha and A, that is unknown current, minus 31.5 minus 31.5, instead of 5 again alpha A, alpha and A, then again minus 9. For equal you can see alpha and equal, alpha and CLC, alpha and equal 0. Then shift and solve, once again shift and solve, you will get the value of current I, that is 0.0212 ampere. Thank you.